BERKEL geoconstruction, gravel columns for sinkhole remediation. A sinkhole is a natural depression or hole in the Earth's surface caused by karst processes, typically denoted at the surface by either subsidence or collapse of the surface structure. This simplified profile shows fine sand with a thick impermeable clay layer overlying the lime rock with carbonate dissolutions. The natural water table is down in the underlying rock, while an elevated water table exists because of the impermeable clay layer. Over time, weak spots form in the clay layer. This leads to water flow from the elevated water table down to the natural water table in the lime rock. This water flow transports the upper sands through the former clay layer into the underlying cavernous lime rock. When the subsurface erosion becomes large enough, eventually surface subsidence occurs in the form of a depression or outright collapse, as seen in the earlier examples. Traditional methods for treating sinkholes include pressure grouting into the cavernous lime rock to block further water flow through the clay layer. However, this does not treat all water flow in the area, merely diverts water away from the primarily affected sinkhole area. While treating the immediate problem, this diversion of water will, over time, lead to similar problems in neighboring areas. Remediation goals should then include stopping the immediate erosion and sinkhole growth, stabilizing the soil in the immediate vicinity, minimizing the losses of any material introduced to stop erosion and stabilize the soil, and to maintain existing flow paths to avoid creating sinkholes nearby. Installation of gravel columns can accomplish all of these objectives by filling existing voids while not disrupting water flow through existing flow channels. No more subsidence occurs, however, flow is not diverted. Installation equipment for these columns includes a large diameter continuous flight auger with reverse flighting attached to a fixed mast rig capable of applying significant downward force. Additionally, instrumentation for monitoring torque and inclination in real time are included on the rig. First, the tool is drilled or pushed to the maximum target remediation depth. Next, the specified fill material is incrementally fed into the target zone using an increase in torque and crowd to determine when to move the tooling up and continue feeding. Above the target remediation zone, material continues to be fed to fill the void created by the initial drilling. In this example, a large sinkhole leading to the collapse of the surface structure, as shown earlier in the video, has been backfilled with sand. First, the tool is drilled or pushed down to the top of rock to ensure the gravel barrier will be formed between the rock and the overlying sand. The auger will refuse upon contact with the underlying lime rock because it has no cutting teeth, and therefore does no further damage to the rock. Equipment parameters such as the diameter of the auger, the stem, the pitch of the auger, and the rotation rate are all selected based on the subsurface profile to convey the fill material at a rate commensurate to the soil profile. The fill material is stockpiled around the auger as the auger rotates, transporting the fill down into the subsurface profile. The fill material is manually conveyed onto the auger flighting to help facilitate transport into the subsurface profile. Small material handling equipment, such as a bobcat, are often used to stockpile materials around the tooling. Columns are typically installed on a grid of a size to be determined based on the size of the sinkhole and the subsurface profile. As the columns are installed, recording of the gravel volume in each column helps define the extent of the sinkhole and the area of treatment. In conclusion, the low mobility of gravel, particularly when compared to a fluid grout, prevents excessive amounts of material from being placed in the rock formation. However, the volume of gravel introduced is sufficient to fill existing voids and stabilize loosened soil. Also, the gravel may be sized based on the subsurface profile to prevent overlying sands from further eroding into the rock. Additionally, the high permeability of gravel allows the groundwater to continue to drain at the current location, which avoids encouraging new sinkholes. A further benefit is that the installation by continuous flight auger does not introduce vibrations, which could further destabilize the sinkhole. BERKEL has offices nationwide available to assist you. Please contact us at your convenience for further information about this or any other BERKEL geoconstruction service. Thank you.